Dear students, मैं डॉक्टर संगीता शर्मा, एसोसिएट प्रोफेसर, डिपार्टमेंट ऑफ केमिस्ट्री, गवर्नमेंट इंदौर कॉलेज बीकानेर। आज हम एमएससी प्रीवियस पेपर थर्ड यूनिट 4 सरफेस केमिस्ट्री में सरफेस फिल्म के बारे में। There is enough evidence to show that when a slightly soluble substance is kept on a liquid-air interface, it may spread out to a thin, mostly monomolecular layer is known as surface film. This may be regarded as an extreme case of surface adsorption. Focals show how film could be confined by means of the barrier. She found little changes in the surface tension of fatty acid film until they were confined to an area corresponding to 20 angstrom per molecule, which is known as focal point. Focal point is the area where the molecules of the surface material were just touching each other. One of the molecules floating on the surface with little interaction until they actually come into contact with each other at the surface film. Squeezing a film at the focal point put compressive energy into the film that was available to reduce the total free energy to form more surface, that is, surface tension was reduced. The monolayer film could exist a physical forces on a floating barrier. Langmuir confined the film with a rigid but adjustable barrier on one side and with a floating one on the other. The film was prevented from leaking past the end of floating barrier by means of small air jet. The actual force on the barrier was then measured. Give film pressure pi. Suppose gamma 0 and gamma be the surface tension of pure water and mono layer respectively. Gamma 0 pulls the float right and the surface tension of the mono layer covered water. Gamma pulls the float towards the left. Since gamma is less than gamma 0, there is a net force per unit length on the float of gamma 0 minus gamma towards right. This force is called the surface pressure pi. This is Langmuir surface balance to measure surface pressure or film pressure. Film pressure or surface pressure is the surface tension of a liquid is lowered by the addition of a solute than by Gibbs equation. The solute must be adsorbed at the interface. This may amount to correspond to a monomolecular layer of solute on the surface. Such a monomolecular layer may be considered to exert a film pressure pi, which is equal to gamma solvent minus gamma solution, or gamma 0 minus gamma, where gamma represents the surface tension. This film pressure or two-dimensional pressure has the unit of dyne per centimeter and can be measured directly. Suppose the adjustable barrier is moved to the right. This decreases the area A available to the monolayer and increases the adsorption. The increased adsorption of these surface active molecules further lowers surface tension and increase surface pressure. At point C, the film has been compressed sufficiently to bring the molecules of the film almost into contact with with one another, so that the film strongly resists further compression. The area A0 focal point is divided by number of molecules and give cross-section area per molecule. Lanier found that one could sweep a film of the surface quite clearly by moving the sliding barrier, always keeping it in contact with the surface. The floating barrier was connected to a knife-edge suspension by means of which the force of the barrier could be determined. A film is a monolayer of substance spread over a surface so that gravitational effects are negligible. A duplex film consists of two interfaces, e.g. liquid film and film air, are independent and possess their separate characteristic surface tension. In addition, material placed at an interface may form lens that is thick layer of finite extent whose shape is constrained by the force of gravity. Criteria for spreading of one liquid on another. If a mass of substance placed on a liquid surface present in a layer of appreciable thickness, then two possibilities exist as to what may happen. At constant temperature and pressure, a small change in the surface free energy of system is denoted by dG and given in equation first. But dAB is equal to minus dAA is equal to dAAB. The coefficient minus delta G upon delta AB at constant area gives the free energy changes for the spreading of a film of a liquid B over A and is called spreading coefficient of B on A, which is given by SPA is equal to gamma A minus gamma B minus gamma AB. SBA is positive if spreading is accompanied by decrease in the free energy, that is, the process is spontaneous. Work of addition WAB between two phases is WAB is equal to gamma A plus gamma B minus gamma AB. WAB is work necessary to separate 1 centimeter square of interface AB into two liquid vapor interface A and B. The work of cohesion is WBA is equal to 2 gamma B. WBB is reversible work to pull apart a column of liquid. Spreading coefficient is SBA, which is equal to WAB minus WBB. A thickness of duplex film of B forms when one liquid is placed on the another. If S is positive, then this happens when a liquid of low gamma or surface tension is placed on one of high surface tension. When two substances are in contact, they become mutually saturated, so that gamma A will changes to gamma A in B and gamma B to gamma B in A. In benzene water, HBA is equal to 72.8 minus 28.9 plus 35.0 is equal to 8.9. 72.8 is the surface tension of pure water. 28.9 is the surface tension of pure benzene, and 35.5 is the surface tension of inter SBA upon A is equal to 72.8 minus 28.8 plus 35.0 is equal to 9.0. The surface tension of benzene decreases due to the mixing of water. SBA is equal upon A, B is equal to 62.2 minus 28.2 minus 35.0 is equal to minus 1.6. 62.2 is the surface tension of water when it's saturated with benzene. If benzene is added to a water surface, a rapid initial spreading occurs, then mutual saturation occurs. The benzene retards to a length. The water left behind is not pure. Low surface tension liquid will have a positive initial S but a near zero or negative final one. This is because of the film pressure of the Gibbs monolayer is always large enough to reduce the surface tension of the water air interface to a value below the sum of the other two. This organic liquid on water forms monolayer with any excess liquid collected as a length. The spreading process produces some disturbance which is confined to a region immediately adjacent to the expanding perimeter of the spreading substance. One may measure surface tension instead of gamma by means of modern film balance. Modern film balance has various parts. First is the fixed barrier. This is a strip of mica float on the surface of water and suspended from its torsion wire. The second is compressing barrier. This is a floating barrier strip of platinum foil or waxed thread attached at the end of it. This strip are lying upon the water surface and connect the end of barrier to the side of drum. Thus, prevent leaking of surface film past the float. Third is sweeping barrier. It is movable barrier rest upon the sides of the trough and is in contact with a water surface. A number of movable barriers are provided for sweeping the surface clean. It may be raised or lowered by means of a rack operated by square drive rod. Fourth is trough. It is 2 or 3 feet long and 1 foot wide, shallow rectangle tray made up of brass, stainless steel, glass or Teflon. Glass of metal tray must be coated by paraffin lacquer to ensure high contact angle. Fifth is air thermostat required for precise work. Working of modern balance, a tiny amount of insoluble spreading substance is introduced into a clean water surface. Dilute solution of stearic acid in benzene. Benzene evaporates leaving a film. Then sweeping barrier is advanced toward the compressing barrier. The surface film exerts a surface pressure on the float, pushing it backward. The torsion wire attached to a calibrated circular scale is twisted until the float is returned to its original position. The required force divided by the length of float is surface pressure. Limitation: if too much material has been used or spreading is slow, instead of monolayer, patches of unspread material floating on the surface. Second is care to prevent leakage is occurring past the sweep at high film pressure. Third, if film material is added a solution in a volatile solvent, the addition must be slow and such that none of the solution reaches the edges of the trough before evaporation of the solvent. The importance of surface film is first is used in explaining the function of detergent and soap. Second, insoluble monolayer retard evaporation of water. Substance should be non-toxic, easily separable, inexpensive and harmless.